welcome. I'm delighted to give a little speech about this topic of implementation of a new complete yeast propagation plant with the perspective as us as an independent advisor. And most of you probably know all the other speakers. You don't really know my background, so just a little saying where I'm from. That's the company called Alexia. It's a very old engineering company from 1912 that later on bought up the old Danbrew company and Pinborn Technical Service here in the UK. So we right now have 3 main offices in London, Denmark, and also Melbourne, and lots of different projects all over the world, just a few ones on the map here. And it's all from big greenfield to optimization of existing plants and also craft brewing. We see more and more work where we have to help craft brewers as well. So we work with all sizes, and we have around 70 brewery specialists working with the process, packaging, utilities, and logistics. And this is not just beer, it's also soft drinks, ciders, and spirits, actually. But what I want to talk to you about today, I'm not going to tell you how to do a proper propagation or exactly how the method of implementation should be. What I want to go through is and tell you is there's more to consider than you think for a new propagation plant. That you have to not just consider the current state of the brewery, also the future state of the brewery. So from my perspective, go in and see, okay, how would I implement a new yeast propagation plant? I will use perhaps a specific kind of model that I would like to show you. And why is it that we want to use this model? Why is it that we want to go through all these initial talks, questions, impact from the process, considerations, borderlines to consider, also the analytical aspects, and the final tendering that you have to do before you go out and you buy your actual propagation plant that you're going to implement. So all the essential areas. So first of all, why is it that we want to implement it, as I'm going to talk about? Well, talking propagation, then, first of all, it is to produce as much yeast as possible in as short time as possible under sterile conditions with a metabolism so you lead to normal fermentation, consistent quality, and very important, performance, consistent performance. This, when you implement a propagation plant, it highly depends on your type of brewery. Are you a craft brewery? You have lots of seasonal brands and smaller brands that you put out all the time, different kinds of yeast strains, for instance. Are you a regional brewery? You have a few standard products and a lot of seasonal rarities. Or are you a big national corporation producing mainly perhaps lager beers and using 1 or 2 types of yeast strains only? And also, the state the brewery is in, and when you want to implement your propagation plant. Is it a greenfield brewery? You're starting up a whole new craft brewery or a big brewery. Well, then you have the delicate opportunity to design your propagation plant from the very scratch so it can meet all possible scenarios. Or if it's a existing brewery, you want to implement a new propagation plant, then you have to consider the process at the brewery, setting specifications, requirements you need to follow. This might look a little bit scary, so I don't want you to focus on all the text, just focus on the top phases. This could be when you have a project in a brewery. Normally, all the phases will be used for a larger brewery or expansion of a brewery. But as I see it, these different phases when you're working in the brewing industry, the project defines the phases. So if you just want to expand a new brew house or a beer processing area, then you can do an analysis, conceptual design in the beginning, how to do it. You just go in and see, okay, how would we optimize running a production? Or as this case, where we're implementing a yeast propagation plant, then what I will focus on here is the initial part, the analysis, the planning and design, all the things you have to consider in order to implement it. And then how to move on from there into the final tendering and contracting. And the reason that we want to do this is it's crucial to have gone through all the right initial questions, alternatives, solutions, and risk that these might involve. This is just a conceptual graph to show you what it is I want to tell you. Because if you in the beginning start asking all the right questions, you go up, you earn more knowledge. What is it that your plant needs to, what should the functionality be? So what is your requirements? The less risk there is that you actually end up buying something that do not fit your requirements. For instance, you just go out and say to a supplier, I want a new yeast propagation plant. They say, yes, here you go. You get the standard solution. but that might not fit with what it is that you want. And in the end, having this solid initial talks and conceptual design and analysis prevents you from going back and do changes, which actually in the bottom line is money. Because if it doesn't fit your requirements, you have to alternate it. So reduce additional cost and lack of functionality of requirements is what you gain by doing this way. So to go in and look a bit about the clarifications, considerations, and risks. Well, the first initial talks is going to be the foundation of your propagation plan. There's just some examples to consider that I would start out with, for instance. Your forecasts and trends. Are you a craft brewery or regional brewery? You have your standard products, and then suddenly sales departments say, we need to have more smaller brands, more seasonal varieties, and these can be with lots of different types of yeast strains. You increase your number of yeast in your brewery. And also, if you go in and say, but does this fit in the current and the future? And we've seen this a lot in the bigger breweries also, and in the regional breweries, that they want to produce these more craft brewing products. So we go with high hops, high alcohol, which leads to longer fermentation. And sometimes you have products that as you said before, might be able to repitch again. So this will put a larger pressure on your yeast propagation plant. Also, you have to consider the level of automation. You're having a fully automated brew house, you need a fully automated yeast propagation plant. Make sure it can be integrated into your braumat system or whatever it is that you're using. Or do you have a more semi-automatic or manual brewery? Well, then there's perhaps more a question about the manning and training for using the propagation plant. And then finally, also the investment and the capex. What is it you want to buy? So that's also the issue. Then the impact from new integrated technologies. I had a case where a brew house wanted to start using isomix in all their tanks. We were going to design a yeast propagation plant. Then we could consider, we know that for integrating isomix or the EcoFerm system, you improve your fermentation performance. So perhaps we could go and pitch with a lower concentration and design our yeast propagation plant accordingly. But the brewery didn't have a lot of knowledge in using isomix, so we had to consider, okay, you have to do trials because wort types have an influence to high gravity. Also, the sizes of the tanks can have an impact on the actual performance of an isomix. And I saw some tests where if you went up really high gravity, the isomix improvement on the total fermentation time didn't improve that much, actually. And also, when you go into the brewery and want to design a propagation plant, are there any standard procedures, requirements, or specifications that you need to follow or align? It could be purely process equipment-wise. So to say, okay, the tanks need to be with this headspace. We will only run with this back pressure. It can be the case. And operation regarding the CIP, always the biggest question, how do you run your CIP? Or are you a group taking over an individual brewery? Well, they might have different ideas of methods of carrying out propagation and procedures, which you have to align with your own. So the planning and initial topics, there's more into it, has a big influence, and you need to settle this from the very beginning. If you then dig a little bit deeper into the process, the impact from the process parameters, when implementing a yeast propagation plant, you cannot just look at that as an individual unit. You have to look at the complete yeast management system. So the whole yeast cellar, waste yeast, fermentation, UTs, etc. And also, how often do you plan to propagate? And that goes back to what we just asked before, the initial questions, planning forecasts and trends in the future, or what type of brewery philosophies you have. And then, of course, go into what is the number of pitches a day, go back to how much can the brewery delivery of brews, compare also with the size and numbers of FTs, UTs, and the number of generations allowed. Because some breweries, they accept just a very low level of generations because they're afraid of loss of vitality or loss of the actual properties of the yeast. So if you have a brewery where you have a high number of pitch a day, or not a day, but in general, and low acceptance of generations, then you put a high pressure on your yeast propagation plant. You also have to consider the composition of the different worts. Some breweries use a lot of adjuncts, And in that case, you might end up having quite a low fan in your wort for propagation. And then some brewers say, okay, then we want to use our all malt wort, to use the propagation. But then again, is that according to your specification? Are you allowed to use one wort for the propagation and another one for the fermentation? What will the impacts be? You adapt the yeast to one type and use it in another. And also, what is sterile? Do you take your hot wort directly from your yeast propagation, before the wort cooler, into a yeast propagation plant? You say that's sterile? Or do you sterilize it additionally in the propagation plant? I actually seen this. Or do you take the cold wort straight after the wort cooler, put it into your propagation plant, and accept that as sterile, saying that you clean your propagation plant properly? So also operational, how do you put it in here? And your SIP standards, evaluate these accordingly. And I'm gonna give you a little practical example with the brew sizes and their influence and matching. But just to see, take away from here is the propagation plant needs to be seen as a bigger part of the process. This is a recent case where we had to implement a new yeast propagation plant. We had in the brewery, had to use both new and existing fermentation tank. We only had two sizes, a medium size and a large size fermenters, and had varying brew lengths. There was a really big difference between the lengths of the brews coming in due to a new brew house and sales department, kind of different products and load on our mass filter. The tricky part here was that we had to match with the cooling jackets. So the different brew lengths had to match according to minimum and maximum distances to top the cooling jackets to avoid freezing or hot zones. And the propagation plant, furthermore, we had to consider that we were putting in a whole propagation into this, had to match the cooling jackets as well, and also our pitching rates. Then some might say, why didn't you just pitch it into one of the larger tanks and with a lower fill? It'd be easier than trying to design the new tanks and see if the old tanks were matching. But then we would be using a large fermentation tank, half utilization. That's not beneficial, is it? So we also had to take that into account. So this is just to show that sometimes or often you have to go much further than first anticipated in your thinking process when implementing a yeast propagation plant. You also have to follow and consider your pitching rates from propagation to the final fermentation. How do you do your dilution in the end? Is it purely based on your Plato? Is it cells per milliliter? Is it just a dilution? So in some brewers they say we just want minimum 1 million cells per milliliter when you pitch in the first time during the propagation steps. And also, as you came in on before, the blending of zero generation into the final product. For instance, if you have a topping up policy for your propagation in a big tank, you end with let's say a drastic example, 4,000 hectoliter fermentation tanks. That's your zero generation. That's the one you need to blend in with a normal fermentation product. That means I've seen regimes of blending 1:4, 1:1. Standing with that case, put a lot of pressure downstream in your brewery and on your buffer capacity. So that are things you have to consider as well. And as the case before with matching the tanks, if we had to match the propagation plant with the bigger tanks, then we would need such a big propagator that we couldn't have it inside the brew house. So how to go around these things need to be considered. A different case when we look at impact from the process parameters is the method. There's plenty of different technologies to choose from when you want to propagate. Here we had two different propagation systems, with a small one of 30 hectoliters and another one with 200 hectoliters, two-step. And we asked the suppliers to bid in what is your preferred technology to use here. And one supplier said, okay, we're going to use the method where you do the circulation and aeration in the loop for both propagators, the small and the large one. And the other supplier said, we're going to use aeration from the bottom in the small tank, because that was sufficient, they said, for both as an agitation and aeration, but they wanted to put in the circulation for the bigger propagator. So how do you guarantee this, that you have sufficient agitation, I ask, for the smaller one? And why did they choose different technologies here? You can also go in and look at completely different technology with having an actual agitator in your propagator. A lot of brewers are frightened by this moving parts in your propagator, possible dead zones. This is sterile. But so there are several technologies and concepts to use, but you have to make sure you can guarantee that, for instance, you get homogeneous dispension, that you get the maximum cell count that you plan to use later on in your brewery. But how do you measure, control it? You want to use special equipment to do this, or an example, you can go to references, other breweries or cases where they've used this before. It's a good idea to go and try. But always make sure that suppliers can guarantee that they actually fulfill the stuff that you say to them. It could also be your small craft or microbrewery. We're talking European size, not the American size. That's a different league. It might be sufficient with just a simple, single, small propagator, just quick, fast production of biomass. If you're a conventional brewery, you don't do a lot of propagation. You just need to propagate when you have some contamination issues or in rare cases. Also had a case with a smaller Scandinavian brewery where we were doing a new beer processing area for them. And when we came to the yeast propagation plant, they said, we just need enough yeast. That's it. So, okay, go from there. Or you can just go and use dry yeast, if that's your case. Just pitch that in. But how sterile is that? So fit the purpose and the need. Don't overdo it too much if it's not needed. Then a quick look into the borderlines. This depends a lot on the scale of the project and where you're implementing your yeast propagation plan. But I think it's important to notice that if you, for instance, have one supplier delivering your propagator, you have one for the utilities, with the air, steam, cooling media, CO2, and then you have the beer processing contractor that delivers everything around it. You need to make sure who delivers what, where, and to when. Draw up the boundaries, so to speak. And make sure that they fit in to your CRP regimes. And also, do you want a dedicated CRP system for your yeast handling? That's always the question. And where do you actually want to locate the plant? It is an important aspect. You don't put it far away from your wort main or in a wet, not so clean area. So the whole layout of the brewery and where to put it in actually means a lot as well. And that it fits in with functionality and integration to the rest of the plant. And very important, I haven't mentioned this before, but don't forget the laboratory, upstream functionality and preparation. It's very important that if you do a completely optimized yeast propagation plant, if you don't also have an equally optimized and functional laboratory, then it doesn't really make sense. You need to have equal boundaries. Then the analytical aspect. Well, what is the level of monitoring that you need for your propagation plant? Do you just want to check the viability and your cell count? Is that correct? Or is it, you need to think also, what is nice to have? What do you need to have? Some breweries, they do too much monitoring and measurement and don't actually use all the parameters. So only get the equipment for the parameters that you need. It's very essential. It also depends on the yeast propagation plant. If it's fully automated, you might require much more monitoring and instruments for it to function properly. Or if you're a more manual one, then simple samples and simple measurements might be sufficient. You can also go full in and do what we call quality by design, where it's all completely running by online monitoring systems. That's perhaps a little bit far out. And also, what I've shown here is the different ways of measuring. You can do the traditional offline laboratory. Person will come, take the sample, analyze it. A lot can happen in this route. You can have your online or your inline, but then you need to make sure that they are long-term stable. Their resistance to your high temperatures and different pH ranges, the calibration, high and low concentrations, and that your personnel are actually skilled enough to use these and calibrate them. And there's no interference during your measurements and your process. What we see more and more now is that you have what's called at-line. You have the operators takes over the laboratory personnel's task. So you have your control room, that's just next to the process. They run out, take the sample, and do the measurements. So it's changing a lot, needs to be considered. Perfect. So a little takeaway here. In order to control, you have to measure. If you can't measure, you can't control. It's the first one I learned in university. So now we've gone through all the initial talks, what needs to be clarified up front, the impact from processes, a few examples of it, the borderlines you need to consider as well, and also the analytical aspect when implementing a yeast propagation plant. And all this kind of sums into your analysis, planning, design, your basic design when you want to put in your propagation plant. So that's the first two phases I showed here. And then we want to move on to the tendering and contracting. What we do is we take the results from the first two phases, we put it into a more detailed tender document that makes sure all functionality, requirements, guarantees, performances, etc. are in there, and it's solid. And once that's in place, there's little need to go back and do changes. This is your paper you can go out with and get your propagation plant, and the rest is set when you need to implement it. And it makes sure that you also have several suppliers bidding on it, so they can actually say, okay, this is the technology we would use in this situation, but still meeting your requirements and design, and also for the best price. Of course, sometimes there'll always be a little bit of engineering follow-up in the end when implementing it, but it's minimized significantly when you use this method and do all this initial thinking. So some concluding remarks. There are many factors and specifications that needs to be settled when implementing a new yeast propagation plant. I mentioned just a few of them, and I'm sure you have other things that could also be mentioned and thought of as well. And the more requirements and specifications to the beer processing area, the more complex the thinking for the yeast propagation plant becomes, the further out you have to consider. But by going through all these different clarifications, considerations, and risk in the early phases, you eliminate several risks while increasing your knowledge and reduce additional cost in the very end. And this following tender and contract secures and guarantees your previously set requirements and select the best functionality for your yeast propagation plant that you want to use. And that was, thank you for listening.